Secure AWS deployments using IAM roles in GitHub Actions. Hello everyone, my name is Ankush Jain, and in this video I will be talking about how you can deploy resources to AWS from GitHub Actions using AWS IAM roles. With this, you don't need to create an IAM user, manage access keys, and store them in GitHub secrets. So throughout this tutorial or video, I will be using this page, and you can find the link of this page in the YouTube description below. Okay, so I have categorized or divided this video in few sections, and I will be walking you through all these sections one by one. So let's jump into first section, which is what you will learn. So let me open this. So what you are going to learn as part of this video. So first we will be talking about what is the problem we are going to solve, which is again using OIDC and IAM roles to deploy to AWS through GitHub Actions. Then what is identity federation and how does it work? Because I'm going to talk about this because this is the concept we are going to use. So it is good to know to understand behind the scenes work. Then I will be talking about how identity federation works in GitHub Actions quickly, and then we will move to the hands-on lab where I will show you how you can deploy resources to AWS from GitHub Actions. Okay, so what is the problem? The problem is if you're not using IAM roles or OIDC integration in GitHub Actions, then what you have to do, a typical process is you have to create IAM user in your AWS account. Then you have to generate security credentials, AWS access keys and secret. Then you come to GitHub Actions and you store those access keys and secrets in environment variable or some secrets in your pipeline. So the problem with this, every time you have to build a new pipeline, you have to do this exercise, and because creating security credentials, so whenever you are going to create security credential, it itself is kind of not a best practice, I would say. You are opening the opportunity of leaking your passwords, so your passwords can be leaked or someone can steal them, and because they are generated one time, so there is no rotation of those secrets, and it is we are also not adhering with the best practices of storing. uh, we should not store the credentials in CI/CD pipeline. So with this new approach where we are going to leverage IAM role instead of security credentials directly, we will not be creating any security credentials. So I mean, that's kind of more secure way of doing a deployment. Now this is a quick thing, like I just included. So how do we access AWS console? So there are first way we use root user. So if I go in I mean, I don't need to show it, but yeah, you know it. We use root user to access AWS console. If you are not using your root user, then we will go and create IAM users, and then we'll use those IAM users to create, I mean, to log in into AWS console. And third way is to use identity federation, and there are two flavors of identity federation. One is OIDC, another is SAML. So next I will be talking about identity federation, and which is this third one through which we can access AWS console. So what is identity federation? So identity federation in AWS allow external entities to log in into AWS console, which means, okay, let me read it out again. Identity federation in AWS allows external entities to log in into AWS console. No need to create IAM users, as identities are already present in identity providers such as Active Directory, Cognito, or any other IDP. So what does it mean? For example, you're working in a company and there are hundreds of employees in your company, and your company has an AWS account. Now your identities are already present in company's Azure Active Directory account. So if your company wants to give access to you to their AWS account, they would not like to create again 1,000 IAM users in AWS account and map one with each employee. So what they will say, yeah, we want to use our existing identity provider and also want to grant access to all our employees to our AWS account. And that's what identity federation does. So you don't have to create IAM users. Uh, identities are stored somewhere. We are leveraging those identities, and what essentially it you will be doing. So when you open the AWS console, once identity federation is implemented, you will be redirected to your organization's login page. You will sign in there, and upon that you will be redirected back to AWS console. And once you are redirected to AWS console, you will be basically assuming a role, IAM role, and whatever permissions that IAM role that you are going to assume, you will get those permissions in AWS console, and you will be logging into AWS console by assuming that IAM role. And if I show you here, I'm with the same. So you can see I'm appearing as a federated user and I have assumed some role. All right. So now this is how identity federation work. And this is a quick walkthrough. If you're not much interested in learning how identity federation works, then you can skip it and jump to the hands-on part. But this is essentially in the next part, I will be basically linking this how identity federation works in GitHub Actions. So that's why I'm just completing little theory before jumping to the hands-on. So now what happens in a quick nutshell, you are a user, you have configured identity. So for example, if you go here, I will go in IAM, and here I want to configure users from, I want to configure identity provider. So what I will go do, I will go here and will click on OIDC and will enter a URL. So this URL can be depend upon what OIDC provider I'm going to use. So if I want to use Google, I want to use Facebook, I want to use Azure Active Directory, or in GitHub Actions, we are going to use GitHub Actions provider URL. So we we would decide like where are the identities, I mean, what is the IDP to which we want to give access to our AWS console. So we will provide that here. So now what happens, you are a user, you configure an identity provider in IAM roles. Now it could be Facebook, Google, or Amazon. You go, you sign in with their on your Google account, on Google sign in page. You are redirected back with a JWT token, which represent your ID, which is basically an ID token. So you get an ID token, and what you do then, you send that ID token along with the what role you want to assume in AWS account to STS. And how do you do it? You call assume role with web identity API. So you are passing those things to STS, and STS is security token service in AWS, which returns you temporary credentials which are valid for few seconds. I mean, you can specify the duration, how long you want to, how you want those tokens to live, and you get those temporary credentials. Then using those temporary credentials, you can access any AWS service like you do. So essentially they are AWS access keys and secret key, but they are temporary. So and when the pipeline will run in GitHub Actions, they will follow the same principle. Like they will get obtain temporary credentials from STS, and it will leverage those credentials to deploy resources on AWS through your GitHub Actions pipeline. Okay, so we have got how identity federation works. Now let's quickly, I think I missed one thing, how it works. And then yeah, so if you want to learn more about identity federation, I have provided a link, and you can go through this link using web identity federation. And here you will also find the similar diagram, like login with Amazon, then calling STS, then accessing DynamoDB resources. Then so there are two types of identity providers. One is OIDC type, another is SAML type. I have shown you here. One is OIDC type, another is SAML type. Mostly OIDC type, Google, Facebook, GitHub supports OIDC. Uh, Azure AD, Entra ID, and other are SAML providers as well in the market. So both uses different method to assume role. One is assume role with web identity if you are using OIDC. If you are using SAML, then you have to use assume role with SAML. So if you go click on this link, if you want to dive deep, then you can just read about it. Assume role with web identity, assume role with SAML. Okay, so we are not going to deal or talk about SAML because that is irrelevant to this GitHub Actions discussion. So we will be using OIDC, and here it is GitHub. And again, so there are two types of access to AWS. So one is programmatic access. I should type programmatic access here. There you get access key and secret access key, and with that you can use AWS SDK or AWS CLI. You can provide these access keys and access AWS services. Another way of accessing AWS is console. So for that, there is a way how to get a login URL through once you get these temporary credentials. So you can go through these links, but that is also not part of this discussion. But I just wanted to let you know, like, there are two ways you can access AWS. One is through programmatic, another is console. And yeah, so okay, so now we have covered what is identity federation and how does it work. We will move to the next part, which is how identity federation works in GitHub Actions. So let's open this. So now I'm going to explain you the entire flow through this diagram, and you will know once we are going to do the hands-on, you will get to know like how the things are happening behind the scenes. So first of all, I just want to call out one thing. As I said, you can use Azure AD, you can use Google or Facebook. So every in these identity providers, you are registering yourself. So you are becoming an identity. A human is become an identity. But for GitHub Actions or GitHub, it is little different. Here the user is not acting as an identity. Here the identity is your GitHub repository. So GitHub repository is an identity, and we will get token JWT token for GitHub repository, not for a user. So think GitHub repo is an identity. So I have mentioned here GitHub repo becomes an identity. This is exactly like having a user as identity in Google or Facebook. Okay, so now I will open this diagram. So what happens, and so this is GitHub repo, and you want to deploy, you want to create a GitHub Actions pipeline in this repo. So I'm considering that repo. So what it does, it basically call GitHub OIDC, and you don't have to worry about it. It is some URL. So, but this GitHub repo basically requests an ID token, or which is essentially a JWT token from GitHub OIDC, to which represents its own identity, the identity of GitHub repo. And once it gets that token, this token is basically you can see here it returns that JWT token. Then what we are doing, this is a token, and we are also using an IAM role. So what IAM role I want to assume, or I mean this GitHub repo want to assume. So both information, the JWT token plus AWS IAM role, they are calling AWS assume role with web identity. So this is a method. I will show you how you can invoke this method in AWS SDK or in CLI. But yeah, so this method takes these two information, JWT token plus IAM role, and a bunch of other configuration information. And these information is passed to STS, and STS validates whether this JWT token is a valid token or not. And and a bunch of validation it does, then that I will cover in the once I close this image. And after all the validations, it issues temporary credentials, and with that temporary credentials, GitHub Actions can call AWS services to deploy the resources. And you don't have to kind of implement all this manually. Everything is covered in this plugin, AWS Actions configure AWS credential, that we are going to use in hands-on lab. Okay, so this is a kind of a temporary or an example JWT token that I have created with the help of ChatGPT to show you how does it look. So here you can see three main components I have added in bold. So in the subject you can see I'm getting the repo name and along with my branch. So so this is my repo, this is my username. In case of AWS GitHub organization, you will get a GitHub organization name, and this is your branch name. So for which branch your GitHub Actions pipeline is running. The audience is coming sts.amazon.com, and this is the issuer that you are getting here. So now the ID token is then passed to STS, as I have already said. STS return temporary credential, that I have already covered. STS validates the following thing before returning the credentials, because uh, I mean STS will not return AWS credentials to everyone. It has to validate certain things. So what it does, it validates the JWT token, it validates the issuer. So this JWT token has an issuer, and this issuer is registered in your, sorry, here in identity providers or not. If this is not registered, it will not issue the temporary credentials. And finally, it will also check the trust policy. So because we are passing the IAM role, and every IAM role has a trust policy which basically tells who can assume that role. So here we are specifying a condition, and in that condition we specify like which particular repository. So this is, you can see we are heading a sub, and we are specifying the repo name, and even if we can want, we can specify the branch name as well. So only that particular repo and that particular branch can in assume that role. So it's like not everyone is coming and kind of deploying to your AWS account. So it will not basically issue the temporary credentials. Uh, so STS will not issue temporary credentials. So it validate all those things. So once you get temporary credentials, GitHub Actions uses those credentials to deploy resources to AWS. All right, so I'm going to close this, and now we'll move to the hands-on part. So first, in the first part, we are going to use setup identity federation in AWS Console. So we are going to move to AWS Console. We'll do all the necessary things. We'll set up an identity provider. Then we will create an AWS IAM role along with trust policy. And then we will move to the second part where we will be creating a pipeline. And through that pipeline, we are going to deploy resources in AWS. One more thing, so this is the reference link that I have provided and I have opened here. So basically my entire video is basically is kind of a video version of this blog, because they AWS has explained everything very well here. So now I will be using that blog in subsequent step. So just wanted to call it out. So now hands-on part one. Uh, First, we are going to create an OIDC provider for GitHub in your account and refer this blog. I will open this blog and we'll move to a part where we are creating an OIDC provider. So uh, it is saying all these things IAM console. So I am just going to copy this URL from here, and I will go here in identity providers. I am already in IAM role, and I will select OIDC. I will enter this, and next what I will do, I will, for the audience, I will use sts.amazon.com. This is the okay. Now that's all I need to do. So with this I'm basically allowing the GitHub to basically assume some role in my account. So I have added identity provider. Now what next thing I need to do, create an IAM role and scope the trust policy. So I will create an IAM role, and basically this is the uh, naming convention that I have thought of, because for it is that personally I think we should create one IAM role for each repo rather than using single IAM role for all the repos. So this is the practice I came across, which I think good enough for me. So I will go and create an IAM role with this name, and I will go in IAM role, will select create role, and here I am going to so it is asking me trust entity. Trust entity means it will add a trust policy, and trust policy means who will basically assume this role. So not an AWS service like EC2 or Lambda will assume, not an AWS account will assume. Here we are going to go with the custom trust policy. Now in the custom trust policy you have to provide a policy where you have where you will define who are going to assume this role. So I will provide the name later. I will copy this and this entire thing you can also find here. um, to create OIDC, sorry, create IAM role and scope trust policy. So you can find similar thing here. Yeah, so you can find the similar policy here. They have added audience as well, which I mean I forgot to add, but yeah, that's fine. Yeah, I have added here, sorry. So I will copy it, and I will copy it in a notepad, and I will have to replace account ID and the repo name or a username or a GitHub organization name and the repo name. So what I will do, I will just copy it. I will delete this. I will paste it here, and for account ID I will go grab my account ID from here, and I will replace this account ID here. Then for the username, so my username is I know this is Ankush358, so I will update the username here. Or what I can do, we can first create a repository. So let me create a repository. Just a minute. Yeah, so I'm going to create it. So this is the repository AWS deployment demo we are going to use, and uh, let's keep it private for now. Create a repository. So the repository is created, and this is the username and repo name. So I will go here and I will replace this entire thing with this. And see, I don't want to kind of have a very branch specific permission. I want that every, I mean, my GitHub Actions pipeline running in every pipeline should be able to deploy resources on AWS. But yeah, if for your use case, if you don't want other than main branch to run or deploy resources on GitHub Actions, then you should definitely specify more restrictive permissions here. So, but yeah, and I'm still getting the warning, but yeah, that's fine. What warning I'm getting? Yeah, so here specific GitHub repo branch is recommended. So using a wildcard is not suggested or recommended. Okay, so now, that's a trust policy that says what GitHub Actions or GitHub repo, I mean, which GitHub repo can assume that role. But now coming to the permission part, how much permission that repo will have or the pipeline will have. So I will select administrator access, uh, which would have, and you know, most of every permission to deploy every kind of resource. But you can again, if you are following least privilege principle, then you can create a policy which provide access to limited deploy limited resources. Then I will go next, and here in the role name I will enter the role name. So I will go here, and this is repo name, and this is my repo name. So this is the role for that particular repo, and I have provided, yeah, so this is the exactly GitHub admin role for repo name, and this is like, okay, so this is trust policy, and I'm going to click on create role, and my role is getting created. So let's see what is next. Okay, so I think the step third is already done. We have assigned this administrator access policy, and I think we are done with the hands-on lab part one. And here I have added a note: scoping is needed so that only a particular GitHub repo can assume the role, right? So basically, what if you don't include this condition? However, AWS I mean console will not allow you to create a permission without condition. But if you, for example, if you even exclude it, then what it means, anyone, if they know any GitHub Actions pipeline, like not yours, for example, any other GitHub Action pipeline can deploy to your AWS account if they know what role they need to assume. So this is very essential, and you must add these conditions here. Okay, but yeah, I mean, however, you will not be able to exclude it anyway. So just closing it out. So now what we are going to do, we are going to do deploy to AWS from GitHub Actions, and we have already created a repo with this name. And now what we will do, I have already created a GitHub Actions pipeline, and I will walk you through what I'm doing. So what we will do, we will create a GitHub Actions pipeline in our repository. So we'll use this name, and I will create new file, and so inside GitHub workflows OIDC S3YAML, and I will copy this and paste it. Okay, so okay, let me create it. Commit changes. Cool. Copilot is thinking. Commit changes. So my pipeline will not get triggered as I have not enabled auto trigger. So let me walk you through what I'm doing. So workflow dispatch is manual. I will manually run this GitHub Actions. So this is my job test AWS OIDC, which will run on Ubuntu latest. And these are the permissions, two permissions which are required. You can find in this blog as well. And uh, I mean, they are basically related to some ID token and OIDC stuff. I have not dived deep into these, but yeah, these are required. Then in the steps, what I'm doing, I am checking out the entire code. However, my code is there's nothing. But if I need to build some code and then create a zip and then deploy it, then this would be needed. So I am checking out the code, and then this is the main part, very very important part of. I forgot to update IAM role, which I guess I have added a step here, but I forgot. I will re-edit it. Uh, so what I'm doing, I'm making use of this AWS action configure AWS credentials. I'm specifying the reason, what role I need to assume, and a role session role name. And what does it mean? It is basically this step will basically obtain you temporary AWS credentials, which we understood here, I guess. So this is AWS Actions. This is the plugin that is doing. So it will basically call the OIDC get the token, know the IAM role, because we are passing the IAM role here, and it will internally call STS and will provide you AWS temporary credentials, which will be part of environment variable where your GitHub runner will be running. So subsequently, I'm using AWS CLI, so AWS STS get caller identity, which will basically print your identity who is running this job. And then I'm creating a job, then I'm creating an S3 bucket, and the bucket name would be start with GitHub OIDC demo, and then the GitHub runner ID. So it would be one, then two, and then as per the pipeline, and then we will print it and we'll call it. So if we are able to create this S3 bucket, which means our OIDC or AWS deployment is working with IAM role, and we have not created any IAM user or credentials. We will be using simply an IAM role. Now I have to grab the IAM role ARN. So I will go back, and this is the role that got created. So I will go here. I will grab the ARN, and I will update this file. So I will go here, and here is the file. Okay, now I will update it. Commit changes. Copilot is thinking. Update IAM role ARN in TK. Okay. Now I will go to the actions tab, and you can see I can find OIDC AWS test. This is the workflow, and now I will basically trigger this workflow from branch main. Now it is running. I will click on this again, and you can see it is running. I will open. I will click on this job. Okay, so waiting for the runner. It is checking out. However, there's nothing. So you can see it printed this. It executed this command. It got the account ID and user ID like that, and then it created the bucket. And you can see this is the bucket name, and it was able to create bucket. It is set creating bucket, post job cleanup, post checkout, and the pipeline is now succeeded. So in order to verify whether this was able to deploy S3 in my account, so I will go and I will go to S3, and then I will basically check with the name, what name. So it created with GitHub OIDC demo 1. So I will check with GitHub OIDC. So you can see this is exactly in the time 1 minute ago it created this bucket, which is as of now empty. But yeah, we are able to deploy the resources to our AWS account from GitHub Actions, and we did not created AWS access keys. So yeah, I think we are good enough with the demo. Let me close it out, and in the hands-on, let me scroll down. So yeah, we have done both the hands-on lab, and now you understand how to deploy the resources. So in the cleanup part, I will delete the GitHub repository. So I need to delete the GitHub repository. Then I need to delete the IAM role that I created. Then I also need to delete the identity provider uh, that I created in IAM role. So you can do this exercise at your end. And I also forgot to add the S3 buckets that we created. So we also need to delete that S3 bucket. And this is the reference of the block that I was I kind of leveraging throughout this video. So yeah, I mean I hope and this is the diagram which basically give you high overview, high level overview of how does it work. So I hope you have liked this video, and if you really like this video, please do a like and drop a comment. And thank you very much for watching.